Hello there. Just going to change the camera focus. Yes. So, hope you guys are doing well. On my side, I'm okay, a bit tired. So, on today's menu, we are going to watch a video and trying to redo the same. I'm going to share the video on the other screen. Okay. Oh, wait. Okay, now. Nice. So we are going to watch the dissecting Pokemon Red save game from Live Overflow and trying to redo at least the first half of the video, which is trying to edit the save data from that game. And then later there is also a part with Ghidra. I don't know how to pronounce that. Oh no, it's not the same. I need to find no, it's another video. But yeah, we can check that later. But for now, I guess that would be interesting to dive into that field, trying to reverse some Game Boy games, and yeah, that's going to be fun. You just need to check on the stream if the audio is okay. Okay. Now I can hear myself in double. Now I can hear myself. Let's try.
Obsessed with this game and I loved exploring it. Obsessed with this game and I loved exploring it. Of course, the glitches or cheats were fascinating. And I might now the glitches or cheats were fascinating. And I might now the glitches or cheats.
Okay. Let's see. Okay. Let's see. Okay. Let's see. Okay. I think it should be okay on the stream. The sound is not too loud, but I guess if I want to speak, I just need to pause the video, and I'm going to share the link in the chat. So I would recommend to subscribe to Live Overflow channel. He's doing a lot of videos and also with Stack. Oh fuck! I think I forgot. Wait, let me just Stack Machine. Yeah, Stack Mania. What the fuck? Yes, also that guy YouTube channel. Don't hesitate to subscribe. Those are very interesting videos, and that gave me some ideas for my next project. Maybe I can already spoil. So maybe on another stream, this one will be like a series of videos. And oh, wait, I saw someone in the chat. That's the good emoji. What I was saying, I don't remember. Yes. So what I don't remember what I was saying. Yes. So this, I think it will be a series of videos. This concept. So playing with Ghidra and some Pokemon games or Game Boy games. And the next one, I want to learn how to use KiCad. KiCad. Let me just share that with you. That tool. It's to build PCBs, and also it will be related to Game Boy game and Flipper Zero. But that will be interesting to build a connector for the data link. You know, it's the cable that you plug between two Game Boys. So you could actually plug one Game Boy to a Flipper Zero, and using an application, you can like exchange Pokemon with the Flipper Zero. So that's pretty fun. Are you going to build badge? Yes, that's also in my plan. Sorry, drink water. But For that, I need to learn how to build PCBs. So I'm going to start with something very easy, uh, and then slowly building something. And yeah, the main goal would be to build badges. That would be like cybersecurity badges, like you have in a cybersecurity event. That's so cool. Water is life, exactly. I'm going to try something so we can see the chat in the same time. Perfect. And let me know if the the live is laggy, you know, because I'm on Mac Air, my MacBook Air, and it's very hot. So yeah, it's very laggy. So let me know, okay? And let's see.
Be able to understand how they actually work. And for this, I'm teaming up with my friend over at the YouTube channel Stack Smashing, or formerly known as Ghidra Ninja. He had to change his name. Excellent hacking channel.
Okay.
Go subscribe. Anyway, in this video,
So yeah, like I said, I'm going to try that manipulation that he's going to do on the video. For that, I will need, wait, an emulator. Wait. Oops, sorry for the sound. I need to I need to reduce the sound of this one. Yeah, wait. Where is it? Settings. Audio. Ah, yeah, I don't want to destroy your ears. Okay. Let me open this one again. Okay. So I have this emulator here with a real. Yeah, sorry about that. Sorry about that. How is it now? Maybe too much. Like that. Okay, that should be better. So this emulator is pretty cool because you have some debug, show console. Okay. Break debugger. Ah, it's here. Sorry, it's not on the same Windows. And with that one, you could see all the current register of the game, all the instruction, do some breakpoints. That's pretty cool. I still don't know how to use all of that, but later, sure, with much more trainings and lives. Um, and that's pretty cool. And also, you could use Ghidra to import the but the grip. Oh, yes, there. Yeah, much better. So yeah, you could. Let me just. Uh, I'm going to clean my files first because yeah, it will be better. So I have the ROM just there with the game, and I can import that inside of Ghidra and trying to do some reverse engineering, but I still don't know how to do all of that. So yeah, it will come with experience and trainings. But anyway, so the first part will be, yeah, I'm going to just that, boom. Okay, so I just have the ROM here. And first, let's see the video.
I wanted to start by exploring the safe game of Pokemon Red and see if we can hack some.
We're trying to learn some stuff here. Oh, and I want to take notes. Um, where do I store that? Reverse Twitch notes. New note. Okay. I'm going to share my notes with you guys. Don't judge. Here. Okay. Stream one notes. Good. Maybe in full screen, and then I could just do that. Nice. Okay. Let's watch the video. So,
stuff.
il y a aujourd'hui sur le link.
The cool thing about a console as old as the Game Boy is, you have
I hope the
very
sound
advanced
is
emulators
okay.
which you can use to look into the memory of games, even debug.
That's show memory, right? I was looking for the right command. So we can show the there the current memory of the game. Whoops, and that's pretty cool. Just there, and then yeah, you can switch between the space. So you have the ROM with the different ROM. So the second one, third one, etc. Then we have the video RAM, the cartridge RAM that contains the game, and the RAM. Oh, I think it's that one. No? Okay, my bad. I still don't know what I'm doing. And also pretty cool, we have the VRAM, that the space that's containing that contains all the graphics of the game. So as you see everything that is currently displayed of the game. I'm going to start the game. So if I start, so it's slowly changing. I don't have a save, so yeah. Yes, so maybe we need to watch the video first.
Them. I'm using the emulator Sameboy for this. So here I have my personal backup ROM of Pokemon Red, which we can open in the emulator. Of course I own a physical copy of the game, I do not condone piracy.
Me too, don't worry.
Anyway, here's the game running in the emulator.
It's just I don't have it right now because it's in France. But I have one.
Oh, my nostalgia is kicking in. This emulator has developer features where you can open a memory view, and it displays here the whole memory area. But this entire memory is split up into multiple areas, and they are shown here in the drop-down menu. You have the ROM, so this is the code of the game stored on the cartridge.
Okay, so the code of the game. No lies there. No, definitely. I also have one here, but it's not mine. Yeah, the battery is still up after 24, 5. Let me check. Oh, 26 years. So it's still there, still working. Wait, maybe not. Let me try. Okay, wait. So I have that one too in French, but then okay. Let's see. Maybe the battery is dead. Oh, it's working. Nice. So it's still working. Maybe one day I need to change the battery, or else the save file will be gone forever. Because yeah, with those cartridge, maybe I can show you an example. maybe not because we still have paused the video and I'm still talking about something else. But yeah, you have a small battery inside, and because the save file, it's volatile, and if the battery is dead, the save file will be gone forever. Anyway, let's go back here.
You have video RAM, the memory to drive the display. Very important, obviously, your graphics.
Maybe I should take notes.
You have the ROM, so this is the code of the game stored on the cartridge.
Okay, so the ROM. So it's actually the cartridge. Ah, okay. So it's coming from the cartridge. That's the code of the game. Hey, time to take notes. Game stored into the cartridge. Nice.
You have video RAM, the memory to drive the display.
Okay, so that one I knew. Video RAM. Video RAM. Display. That's pretty cool.
Very important, obviously, your graphics card in your computer also has VRAM. And of course, the regular CPU of the Game Boy also uses normal RAM,
Okay.
used during the execution of the game.
So regular RAM, like a computer. Store instructions of the game.
But what is the cartridge RAM?
Yeah, that's what I was thinking about.
Obviously, I also don't know all the stuff, so I have done a bit of research, and there's this excellent website, Gameboy Dev, documenting everything you could imagine about the Game Boy system.
That's why it's pretty cool with this kind of technology, because it's like very old and everyone already did some reverse engineering. So you have the full source code of the like everything from that console, from every bit that everyone did some reverse engineering, and that's pretty cool. Maybe we have an example somewhere. Ah, good YouTuber. Wiki. No, it's not that old. Sorry about that. Um, hardware information. So we are using the DMG. Oh fuck. CPU board. All the schematics. That's pretty cool.
And even the Pokemon Wiki Bulbapedia has a lot of technical resources about the games as well. So most of the stuff I'm telling you now, I know from there. Anyway, you might know that Game Boy cartridges contain
Okay, so it's a good example. I don't have to show what's inside.
a battery, or most of them contain a battery. There are a few games that don't have it. And you might know that the battery is connected to your save data. When the battery runs out, you lose your save game.
That's, yeah, that's not cool. Because a lot of people didn't know that. And well, if you don't have the specific tool to extract the save data, you lose that forever. And that's not cool.
A lot of people have cried the past few years because now we reach the end of life of these batteries they were holding for like 15 years.
Oh my god. I lost one recently actually, but it was not because of the battery. It's because I got a corrupted file data and I lose everything. So yeah, that's not funny.
And the game is obviously older. Nowadays, we are very spoiled with flash memory that can just store data without electricity. But back then, I guess this was too expensive. Anyway, if you want to store save game data or anything like settings or high scores, you need to include this as a feature in your cartridge. And the Game Boy architecture planned for this and dedicated a memory area of the memory map to
Mm, okay.
external RAM. So the cartridges, like the Pokemon games, included RAM. Because RAM is volatile and loses the data without being powered, it had to include a battery. So
Those are those are genius.
basically, the cartridge was never actually turned off.
So it's like a 24/7 game that is running. Those poor Pokemons, they don't rest.
The memory map maps the external RAM from address A000 to BFFF, so only hex 2000 bytes. That's 8 kilobytes of RAM.
Okay, maybe I need to write that, just to make sure that I have all the information. So we have yeah, I forgot the zero hexadecimal from, what was the other one? BFFF. So that's the where is stored the save data inside the cartridge. Cool. And it's about that. Maybe I can do that in Python. Let me try something. Okay, no, my bad. Anyway, wrong window. What did you say about that?
The memory map maps the external RAM from address A000 to BFFF, so only hex 2000 bytes.
2000 bytes. Yeah, okay. Around, well, it's not around, it's 2000 bytes. And he said that it was about 2 kilobytes, 8 kilobytes.
That's 8 kilobytes of RAM. However, for example, for the Pokemon games, you had to store tons of data about the game. Think about it. You need to store which Pokemon you have seen and caught. Each Pokemon might
Yeah, that's right, because there is no way that it will be contained inside 8 kilobytes.
have a nickname and your own set of stats, level, and attacks,
Or you will be very limited.
which trainers you fought against, so much stuff. And it doesn't fit into only 8 kilobytes. So the memory bank controller of the Game Boy supports memory banks.
Mm, smart. Memory banks. Memory banks.
You can imagine banks as simple boxes. Addresses are used to access whatever is in the current box in front of you. Let's say at address A010 is something stored. And now you can ask the memory bank controller to switch to a different box. And then the same addresses, A010, would now return whatever is stored in this new box. And
Oh.
so here in the memory view, when selecting the cartridge RAM, you can switch between the different banks. Bank
So it's inside the cartridge RAM. Let's check that. Bank 0.
0, bank 1, bank 2, and bank 3.
Oh. So there is 3 of them. Well, 4, because it starts at 0. I think so. Okay, interesting. So we have $0 to $3 inside the cartridge RAM.
And looks like at the start of the game, only bank 0 contains some data. Now, this is how we can look at the memory with the emulator. But how does the game itself switch between which bank it wants to access? In the Gameboy Dev Wiki, we can learn how this works. Memory addresses from hex 400 to 5FF addresses the RAM bank number. You can write to it. You can write 2 bits to this, and this 2-bit register can be used to select a RAM bank in the range from 0 to 3.
Oh, okay. So that part of the RAM will hold the bank number. Okay. And it's a 2-bit register from 00 to 03H.
And I find this so fascinating because this memory area is actually part of the ROM.
What? But it's read-only. What the fuck? Oh, it's going to get fun. Uh, let's write that down. It's 4005FF. Holds, oops, holds the bank number 2-bit register, and it's 00 to 0003H. Okay, but it's inside the ROM too.
The game code is at this address area. So how does this make sense? Well, ROM is read-only memory. The game code cannot be modified. It's
Yeah, that's obvious.
burned into the ROM, so it never makes sense to write to it. It wouldn't work. Only reading from it makes sense because the CPU reads the instructions from there or any other kind of data like sprites. So why not reuse the same addresses area for some hardware configuration stuff? Basically, the memory controller is built in a way that when a write is attempted to this specific area from hex 400 to 5FF, it actually controls which memory bank is currently selected. Very clever, right?
Okay, so only this part of the ROM is used for the bank selection, if I understand correctly. So they reuse the ROM space to hold something else, the ROM bank.
Anyway, let's get back to the game.
Okay, that's yeah. I mean, you try to save space, and I get it. So I guess this game was well, this console was well optimized, not like today games and console.
Now we know this cartridge memory should contain the save game data. So let's start a new game and click through the starting conversation until we enter our name. Here let's use some easily recognizable characters, like in exploit development, just a bunch of A's.
Yeah,
Continue and give the rival also a name. I use a couple of A's and then BCD.
let's do that, right? So we are going to uh, um, you get. I lost the window break debugger. Okay. Now we are going to fight the league. I heard the noise. Hey! Oh, that was a follow noise. Okay. Hello, welcome from Canada. Okay. So, new name, and this one was a bunch of A's. Okay. And then the rival one. Looks easy for now. Okay. Can I? Oh, okay. Yeah, I have some cheat code with that one, so I can like fast forward. That's funny. Now I just want to break. Okay.
All right. When you look into the folder of your
Hmm. I don't see any folder.
game ROM, you might notice a .saf file. I specifically trigger a write of
Oh, okay. I need to save. That's why I don't have a save file. That makes sense. Um, how can I save? Oh, enter. Okay. Yes. Yes. Okay. So now I should have the save file. I don't have the save file. That's maybe it is stored somewhere else. What is the default folder for the save file? Okay, I need to check somewhere else. Drink some water. Water. Ah, I don't know to drink. Um, yeah, I don't have the save file, so that's awkward. Let's Google that. So it's in the yeah, but I'm on macOS, so I'm not on Windows. Please. Oh, I think I need to. Wait, let's watch the video.
this by saving the state. This also creates a S1 file, but it's unimportant.
Yeah, we don't need the S1 there. Okay. A small troubleshooting. I just want to know where the save files are located, but for now, I don't have any idea. Um, because if I save the state, it's stored here, no? But not the save file. Or maybe because I break. I'm going just to mute that, please. Okay, perfect. Let's try again. Okay. So maybe it's stored inside the library. Let me check. Same boy, where are you? Hmm, that's weird. Because if I don't have the save file, I can't. Yeah, exactly. What the fuck? Hmm. Is it there? No. Let's check the documentation. Hmm. It is saved somewhere. No. Maybe it's on the. Nope. Vidéo. No. Contrôle. Rien. No audio. Yeah, it's okay. Once I will find it, that will be much easier for the next time. Same boy. Okay. Just going to put that here. No, that's not that one. I just want some hints, please. We are really going to check the GitHub issues. Hmm. I don't have a way to extract. Right. Yeah, no. Well, well, well. How's it? Well, well, well. Okay, let's continue and see, but yeah, I won't be able to do the
Only want
rest.
to have this .sav file. Let's open the save file in a hex editor. I'm using hexfiend here, and then also open up the cartridge RAM memory. As you can see, when you carefully compare the content, they are the same.
Hmm. I want the save file, please. Give me the save file. Okay, let's. I'm going to check on my libraries in my home folder. Um, Maybe the application show package content library. Nope. Maybe. Oh, wait. No, false positive. Those are just the icon of Gameboy and the binaries, but I thought maybe it's in the same place as the binary, but apparently nope. It is stored somewhere, but where? Gameboy. Oh wait, I can just do a mass research from my wall disk on the try to load the game to see if it was really saved. Let's see. Let's see. Oh, yes. So it's saved, it's here. But it oh my god. So yes, Dorota, you were right. Turn it off and on again. Save the issue. I don't know why, how. Okay, so yeah, it's here now. Oof. We can continue. Damn. What were you saying?
I specifically trigger a write of this by saving the state. This also creates a S1 file. But it's unimportant, I only want to have this .sav file. Let's open the save file in a hex.
Ah yes, the hex editor. I have it somewhere. I have the same actually. Yes, thank you. But now I realize that it doesn't make sense because he's also using macOS and it should behave the same, I guess. But yeah. So we have the X editor just there and boom, save file. Wait, did I upload the right one? Yes, sav.
Hex editor. I'm using hexfind here and then also open up the cartridge RAM memory. As you can see, when
Ah yes, cartridge RAM memory. Okay, so this is the cartridge RAM and the hexadecimal viewer X editor. That doesn't look like the same at all. Oh, wait. No, that's not the same. Or maybe bank 0? Nope. Hmm. So it's the save file. Let me check again. Yeah, that's not the same. Maybe I did something wrong here. Is he using the...
hexfind here and then also open up the cartridge RAM memory. As you can see, see, when you carefully compare the content, they are the same.
Nope, they are not the same. I just checked. Yeah, that's awkward. Maybe I don't know. Let's move around, I guess. Put some data somewhere. And, hello. Oh, that's my rival. A B C D. Yo, A. Okay. Yes. I want to save the game. I'm going to close that. And I'm going to um, no, that's not the right one. This one. Save the state. Then close. Oh, I have something. I have much more data, I think. But that's still not the same. If it's not working, I'm going to continue the adventure. That's it. Not really. Maybe I don't have the right. Maybe it's the RAM. No. Oh, that's so cool. It's moving. Bank 0. No. Okay. Anyway, let's see. Maybe I don't know.
So this SAF file is actually a dump of the cartridge RAM, basically storing the RAM over a longer time, like the battery in the cartridge would. So when we work with the save game data, we can simply work with the SAF file. Cool. I actually create a copy of this RAM dump now and name it AAA to indicate this was the save game with the player name AAA. Now let's close the game, delete the save game and restart. Now
Okay, let's do that. Let's do that. Forget some letters in that word.
start a new game and I name the player BBBBB and I name my rival BBBCDE.
Okay, so I guess we are going to compare.
We go into the game again and save the game. Trigger a state save and copy the new save file as BBBB save. So now we have two save games.
I lost my. I think you can't close the game after saving. Okay, let's try. Wait.
From right at the start of the game, with only the names of me and my rival being different. Let's open both files in Hexfiend and then compare them. This puts them side.
Okay. let's try to compare to see if we can see the, you know, the same result. But yeah, let's see. Um, so that one would be A. You, tu dégages. Okay, let's try again. Yes, hello there. Ah, yes, you want to know my name, right? It's going to surprise you. And you too. No, fuck. How do I go back? Oh, nice. Okay, I'm going to move around. Goodbye, mom. I'm going on an adventure. Oh, yes, I'm taking the one cheese to rule them all. So I put the game on pause. I got the save file. Let me compare with that one. Yeah, it's here. Just to make sure. No, nothing like that. That's very weird. Because there is not a lot of data here. I'm not sure. Well, let's compare. No, you don't want. Or maybe I need to close. The fuck? Copy? What? Yeah, let me just compare this one and see, but I'm not sure. So this one is BBB and new. This one is A. Fuck, I opened that. Oh no, it's fine. And then I can compare Okay, that's a lot of stuff. There is too much. Oh, there. That's what we are looking for, right? So it's A, 80, 80, 80, 80, 80, 80. Then let's see the video. Yeah. Is that the same line? Oh yeah, it's the same line. Okay. I don't know why the card bridge RAM was not the same as the save file. Probably I was not using the right one. Maybe it was not the right, yeah, RAM. I don't know. But yeah, so we can see some comparison here.
by
That's
side, and
interesting. Baby steps.
we can easily find the differences. And here's the first one.
Progress, yes.
Look closely. We have here 7 bytes that are different.
7 bytes different. Wow, what's the odd?
The player name was 7 characters long, and all of them were the same.
Let's try to find the rival name. Oh, I think it's here. Look. Because it was 80 and then the rest of the, so it was B B B B C D E A B C D. Yes,
AAA, and all of those bytes are the same. And coincidentally, the bytes for BBB are hex 81, so exactly +1 from the AAA bytes.
that's magic.
Could this be our player name? I mean, it's not ASCII. A capital A in ASCII would be hex for
Yeah, that was what I was thinking about. Is that
1,
ASCII?
but maybe this game used a different encoding for characters.
Hmm.
So if we assume that hex 80 is an A and hex A1 is a B and the name is 7 characters long, we should also be able to find the rival's name. And it looks like this change here could be it. In both cases, we
Okay,
started with the same
nice.
characters, A or BB, and then increment up the characters, 7 characters long. So yeah, this should be the rival's name.
That's amazing. Progress.
Some other data in there also changed, but no clue what that is.
Some other data. Yeah, but on my side, I have a lot of them that are not the same. But yeah, I guess I didn't do the same path, you know. Maybe I should. Oh, the last one is also different for some reason. But the rest here, yeah, it's a full mess. I think, yeah, I'm not going to redo that again, but probably I should like time and do the same. Uh, Probably when I spawn, take a save and then do it again. So I won't have too much data that are not, the same on both sides. Probably how to say that? Not the coordination. I don't remember the word in English, but the emplacement of the character won't be the same too. So anyway, let's see the rest.
And the last difference is this one single
Oh, I think someone follow. I heard the little the little alert.
byte at the end of the area, just before the FFs start. So how about we do a small test? We could try to change our name.
Hello there, welcome.
Let's open the real SAF file in Hexfiend and convert all.
Hello, James. Oh, right. That's the. Yes, that's funny because Yeah, I remember the the LinkedIn clown. Yeah, but it was just during a small time, you know. You are not the LinkedIn clown.
all the
Welcome.
B's, which were hex 81 into C's, so hex 82s.
Okay, let's do that. Wait, maybe let's see what he's going to do first.
Let's save it and then start the game again. Did it work? Huh? Oh man, the
Oh, fuck. I want to try that. But uh, can I do that? I'm going to do a copy of the copy. Okay. Oh, I need to rename it like that. Or you won't be able to find it. Okay. And that one here. So it was the line 9,000 something. Yeah. So C's would be 82. Just let's change just one, just to see and mess around. I want the correct file data, please. Thank you. Thank you. Thank for passing by. See you around. Yeah, I guess it's bedtime. No. The file data is destroyed. Wow, carrément. Destroyed. No. Okay, so we can't change the data directly on the with the hexadecimal. Oh, then did he did he delete the file completely? No, it's still there. Okay, but I guess if I come back, it will say the same. Yes. Okay. That's funny because that's what happened on my Emerald game. I got the file data is destroyed because I was saving, and at the same time the Game Boy just lose battery during the save process, and yeah, that's what happened. Rip, rip, all my badge. Anyway, okay, so yes, so we can't. We know where the data are. Yeah, no, I was very sad too. So I think I still didn't start a new one. I was too sad. I invest too much effort on that game, and yeah. Maybe, yeah, I was thinking maybe I can do that on stream, but maybe on an emulator. Yeah, sad day. For me now, it's a free day, you know, commemorative day. It's
file data is
it's somewhere on my calendar.
destroyed. Somehow our change didn't work. Well, obviously, people have figured out all the details already. It turns out that there is a checksum to make sure the data is not corrupted.
Oh, smart guys, checksum.
This is nicely described on the Bulbapedia article about the save data structure, used to validate the integrity of saved data. The checksum in generation 1 is only 8 bits and has a single copy of it. Guess which 8 bits? So which byte could be the checksum? It's of course this byte all the way at the end.
Oh, so they're taking a checksum of your data to make sure the integrity is not fucked up. Now I'm thinking about maybe I should have kept my save data and do something about. Let me try something. Because I have it here. Did I start a new game? Hmm. I'm going to show you in a few seconds. Yeah. It's in French, but it says that the save file have been deleted, which is not true because I don't delete my save file. But yeah, so it's still in there. So maybe it could be fun to look around. But I don't have the tool to extract the data from the cartridge yet. But I could build it with a Flipper Zero. Wait, let me show you. Where is it? Lies! Oh, it's just there. Here, look at that beauty. That's crazy. I want that. And this one is doing everything. So you can plug the cartridge. You have the NRF24 CC1101, so the RF antenna. You have the ESP32 for the Wi-Fi. You have the cable links. So that's the one I was talking about at the beginning. So to exchange data between two Game Boy. You also have a GPS module for some reason. But yeah, that's beautiful. But I'm looking for only the part of the cartridge. So could be a fun project to make, again using KiCad. KiCad, I don't know how to pronounce that. But for that, I need to learn how to use that tool. So I will try to learn another stream, something like that. Oh, you can plug also the Game Boy camera. That's so funny. And yeah, so you can exchange Pokemon using the flipper, and then you get new from flipper, something like that. Yes, exactly. And once the PCB will be ready, I'm going to order that one, and then we can do some soldering also, like the previous stream. So yeah, that's looking great. But yeah, I will try to build it myself. Not well, maybe not that one first, but the next one will be. Wait, I'm going to show you an example. Um, Here. I hope the live is not too laggy because the computer is like I could cook some eggs on the computer. So yeah, that's looking like that. It's pretty simple actually. You just need some pins, 4 of them. Well, this one is for Game Boy and Game Boy Color. Yeah, Pocket and Color. But maybe build another one for the Game Boy Advance and the classic one, but I think the classic one would be the same. Can I see the PCB in 3D? Yeah, yeah, that's the laptop. It's too hot, and I need to purchase some thermal paste because it's a MacBook Air and there is no fan for some reason. So yeah, rip in Apple. I'm crying money, you know. So yeah, that's an incoming project. I was already looking for tutorial for that one, but I think doing that on live will be much more interesting for me, at least, uh, because it's like learning session. Like you spend 2 hours learning, and you can't do something else because people are watching, and yeah, yeah, that's the schematic. So let's continue.
If this value is incorrect, the error message "the file data is destroyed" will appear. Now, even if you did not know the actual checksum algorithm, you only have 256 options. So if you are really dedicated, you could just try different values until the file is valid. But let's see how the checksum
But that's how much possibility? 255?
calculation works. The algorithm used to calculate the checksum is as follows. Initialize the checksum to 255, so hex FF, and then for every byte from hex 2598 to 3522 inclusive, subtract its value from the checksum.
Okay. So, okay, it's taking the value for all of them, then minus that.
So let's actually implement this in Python. Fix checksum.py script. First, I open the file passed in via the arguments for reading and
Oh,
writing in binary mode. Then I read the whole content into a byte.
yeah, I think the last macOS update was pretty fucked up.
This in Python.
That's a pretty easy script. So you open the argument, which is I guess the save file. You read that as a byte array. You need to checksum. Then from that to that, you do a minus. Wait, so for each bit, he's doing a minus on the checksum? What the fuck? For every byte from that to that, inclusive, subtract its value. Oh, from every byte. Okay, I thought that was the total value subtract by. Yeah, no, it doesn't make sense because yeah. Okay, so you read each byte and you subtract by the checksum. Okay, but then the checksum. Okay, you start that. Oh, okay, I'm confused. Okay, because I thought the checksum was the. Yeah, anyway. No, okay, he stored the value each time inside the checksum, and then he's doing the minus 255. And then he write a new save file. Oh no, first he writes the checksum at the right place, and then write the save file, and then he patch the game, basically. Let's write that. I'm going to move inside my document. Yeah, maybe I need to share the screen. What the fuck? Wait, I have some Python issue. I am okay. I don't remember how to use a terminal. I was doing a Python tree of the file that was not that did not exist yet, and I was surprised because he didn't find it. Okay, so let's import the sys library. So you open the first argument of the script, which will be a file as read bytes. I think it's read byte rb plus as f. Then you store that inside a RAM variable. I have the Pokemon music in my ears. I'm going to dream Pokemon. Okay. Okay, so the checksum is here. So for each byte inside the RAM from this value, so it's literally on the wiki. And I think of those guys that did some reverse engineering on that game. Let's try to indent everything so I don't hit syntax error, please. I don't like eating syntax error, that's not tasty. I prefer the cheese. Okay, so then the checksum is... So here we write the new checksum, which is subtract by 255 inside the checksum location. That's all. Sick. I'm curious about the sick function. Wow. Okay. It changed the position of the file cursor. Okay. So 0 from 0, beginning of the file, to what? Because there is two. Ah, here. Negative offset. So it's like 0, 0. Okay. Interesting. So sick is there. Then we do a f write of RAM. Oh, okay. No, I get it. Here it's going to rewrite the file. That's why we keep the cursor. Checksum. Right. Then, okay. What's the format checksum? It's that format. Okay. Good. And then, so which one was? Oh, that's that one. No, not that one. Don't patch the ROM. And now, let's try again. And it should have changed my name from CCC, I think. Please.
fixed checksum py script. First, I open the file passed in via the arguments for reading and writing in binary mode.
You didn't see anything, right? That's what I thought.
Then I read the whole content into a byte array. We initialize the checksum with hexFF and then loop over each byte from 2598 to 3522. And we subtract the current byte value from the checksum.
Ah, okay. Okay.
In the end, we write the checksum to address 3523. This is where the checksum is located. Now we need to write the changes to the file, so we seek back to the start of it and write the new fixed RAM in the byte array back to the file. Let's execute it and pass in the saf file. Awesome, that should have worked. Let's open up the emulator again and see what happens. Ah, no error, and we can continue our saved game.
Hmm. I don't like where this is going. Let's try again. Okay. Let's see uh, if it's really the good checksum. Too much. I lost the checksum. Fuck. Okay. Let's try with. I'm confused. Compare. What? No. Okay. Here. And the checksum is there. 13584. Let's try on the A. So 82. I can't edit. Oh, okay, it's in the comparison. Okay. 82. Oh, I think I know. It's because I added new bytes, but I didn't remove the previous one. Wait. I'm going to fucked up. Okay. So A. Is that the right one? No, that's not the right one. It's that one. Okay. Remove 82. 82. 2, 2, 3, 4, 5, 6, 7. Ok. Ok. Save. Right. New rename, and then go away. And I need to patch. Okay, new checksum. And now suspense. Oh, yes. Yes. Success. I changed my name. Wow. No, actually, that's pretty cool. Now we can play. That's it. Now we can start playing. Okay. So I think I need to go to the herbs and oh no, no, you can't go there. No, but that's pretty cool actually. Um without the fails and stuff.
And look at that, our name is CCCC now. It worked.
It
Of
worked.
course, you could now use
Oh, maybe not here because I think I won't stay too long on this live. But for next time, that could be fun to, patch the money. Yeah, but maybe I need to write the wiki
our
first.
name is CCCC now. It worked. Of course, you could now use similar diffing strategies to, for
Okay, so it's a diffing strategy.
example, find the player coordinates or level of Pokemons or the items you hold and so
I guess if I try to find the coordinates and then change the coordinates, end up in the ocean, that would be very weird.
forth. Always save the game, do an action, save again, and compare the two. It's fun and can be used to somewhat reverse engineer the save game structure. Of course, people have already done that and it's all documented on Bulbapedia. And so here we could have also learned that the player name is at this offset.
Oh, it was there since, yeah. Okay.
And the rival name is at this offset. Also, I noticed that when
Wait, I'm curious. Bulba PDF. Oh, that's pretty cool. Player name, party data, current bugs, Pokédex own, Pokédex scene. Oh, money. I like money. So it just the size it's 3. Okay, that's fun. Can I walk and put the offset with that one? Let's see. Like not a search, but hmm. Oh, jump to offset. So let's try with the name. That's X2598. Oh, nice. This for the money. That's 25 F. Yeah, you are going to learn the French numbers. I'm sorry about that. Oh, look. It's there. No, wait. It's there. But what's the size actually? Let's see. Money. This is the binary coded decimal. Oh, okay. Let's try something. So if I put, wait, how much money do I have? Oh fuck! And I just talked to this guy. He's going to drag me to his house. Help me! Oh, help! Oh fuck! Hey, hey, j'ai pas le temps. Hey, I don't have time for that. I want to change the money now. I can't see my money here. Okay. Uh, okay. Okay, so that's what I thought. Here, so that's our money. What if just, the it was Christmas and we got some money, maybe bitcoins. Um, Bitcoins facility powered by electrical Pokemon. Then we patch. Okay. And we play. Yes, I'm curious. Please, no corrupt data. Yes! Ah, money is not an issue anymore. Oh, that's cool. That's cool. Fuck. This figure is still big Indian. But what's the limit? 4 bytes. No. No, 6 digit, 2 digit per byte. So yeah, it's 4 bytes. That's so funny. Ah, okay. Well, that was fun. I'm going to save that wiki on the notes. Actually, I didn't took a lot of notes from the memory banks. Yeah, that's pretty nice. That's pretty nice. Let's see the rest of the video. Let's finish at least.
When you have the cartridge view open while playing the game, the RAM is not always visible. Sometimes it's gone. And at first I thought it's a bug, but then I asked Stack Smashing and he figured out how the Gameboy dev documents that the external RAM can be enabled and disabled. Writing to this memory area, a 0 or hex A, will disable or enable the RAM. You can kinda see that when saving the game. As soon as you hit yes, you see briefly the RAM memory being enabled
Oh, that's funny.
and then quickly after writing the save game getting disabled again. I also noticed that when you open the player profile, it will enable the RAM and keep it enabled. So that's very convenient.
And then just close the game. Anyway, I trust you.
Also in the debugger of the emulator, you can type in CA for cartridge to get some info. And you can see, for example, that this particular game cartridge includes battery-backed RAM of the size 8000 bytes, and RAM is currently disabled. But when you open the profile and check again, now the RAM is enabled. Cool. It's so much fun to play around with it. You should try if you can make your own Pokemon level higher or make yourself rich.
Yeah, that's already the case. But yeah, that will be fun to mess up with the Pokemon IDs and level.
As I said, I'm collaborating here with Stack Smashing, so check out his recent video about
Because I guess even the old of data are somewhere, the the health of the Pokemon, the capacity and stuff. I guess everything is in there. Defeated gyms. That's cool. Town visited. Oh, Pikachu friendship. What is that? Oh, X and Y coordinates. Pretty cool. Okay.
the Game Boy copy protection and how he tricked the Game Boy using an FPGA.
Oh, that project also will be very fun.
Very cool video.
But I need a Game Boy. Oops. I need the DMG01. I only have a Game Boy Advance, so not sure it's working the same. Anyway, so I guess that would be it for this stream. Uh, yeah, just checking around. So yeah, next I need to find a time, schedule something for maybe this week or the other week to start using KiCad and building some PCB. I found a pretty cool tutorial that maybe I could follow. It's a guy that's built a PCB live, and it's pretty interesting. He explained a lot of stuff, and that's it's not a 2 hour video. It's like 20 minutes. So yeah, that will be the next one. Uh, Maybe I should also schedule a Hack the Box one. Let's see. Maybe not Hack the Box because my computer can't really handle the Kali Linux VM in the same time as the OBS. So yes, and yeah, I need to order some piece because maybe I can show you also. Let me go on YouTube. Oh, and I'm going to upload this VOD on my YouTube channel. Maybe just to keep tracks of the progress, you know. Wow, please. Okay, anyway. So yeah, I was going to follow Ray J tutorials. So I did that on the previous soldering live, building. Maybe I have it somewhere. No, it's not here. I built Flipper Zero module following his tutorial. That was pretty fun. Soldering stream, I like that. I just need, well, I don't have a good soldering iron, but it will come later. So yeah, I built CC1101 module for the radio frequency. It's just a bigger antenna. And oh, someone else follow. Hello. I can't see the name because I didn't set up the the alert. So yeah, that's this channel, Reggie. I can pass that on the stream if you guys are curious. He's doing pretty interesting tutorials of how to build Flipper Zero module, and the one I'm looking for is the DIY infrared sniper. So it's just taking apart infrared flashlight from AliExpress and then build inside a module. What the final project, please? Yeah, that one. Here.
You just want to go into
That's really
Infrared
cool.
IR.
Because the range on the infrared from the Flipper Zero is not that great. So if you have a sniper, that's even better
Quite
for
close to the
doing good
TV,
stuff,
the beam is
obviously.
going to be very direct. So you're going to have to probably point it at the
You run away from hardware hacking. Yeah, I'm trying to build some skills on hardware hacking. Uh, I've done some talks about that, the basic ones from UART shell, SPI extraction. Uh,
TV.
I have some videos that I didn't start doing them, but it's like it's in the buffer for the YouTube channel about basic hardware hacking. I have some videos also for basic, like getting a shell with UART and stuff using the Flipper Zero and the Bus Pirate, but actually you can do that with USB, USB, UART USB. So yeah, I wanted to create a small video like the requirement for hardware hacking, basic stuff if you want to start, maybe you need a starting point, some ideas and some tools because the issue with hardware hacking is like it's a uh, physical domain, so you need to purchase device. It costs some money actually. It's not like you run a VM and then you do your stuff. But actually, you can do that with the firmware. No, firmware. That's the right pronunciation. You can do some firmware emulation. I'm also looking at that, but yeah, that's a lot of project. The to-do list is maybe too much, but yeah, it's it's coming. I don't know when, but yeah, that will be it. Uh, Also, I have found an espresso machine, coffee machine, and maybe that would be interesting to, dismantle that one doing a live and see what's inside. Because that one has some Wi-Fi capacity, some Bluetooth. So yeah, maybe we can dig around and do some stuff. And yes, oh fuck, 82 follower. Wow. Last time I checked, it was 75. I need to do a post about that. And yeah, that will be it for this live. So almost 2 hours. It's 1 hour and 50 minutes. So yes, I guess I'm going to stop here. Just cleaning the mess here. I hope it was not too laggy. Uh, it's funny because I wrote Ghidra in the name of the live, but actually I didn't use it yet. Okay, maybe for the uh, for the show, I can run Ghidra. Also, I want to do that on another live. Yes, thank you. That was very interesting, even for me. I learned some stuff. I hope you learned some stuff too. Thank you. Goodbye. And yeah, let me just show you some Ghidra content because it's on the title. So what I did, I imported a an extension to read the Gameboy ROM because it's not supported by default. But the issue is that I'm not sure it's well implemented because I have a lot of errors. But that could be a next project because also following Live Overflow and Stack Machine videos, they play around with Ghidra and some Game Boy stuff. So it could be a good start to do that on live too. Here. So I just imported the ROM card bridge. Oh, inside the offset. Where am I? Let's see some function entry point. That one. Yeah. So yeah, that's something else. Also, I need to learn that. Um, I'm not sure starting with the Game Boy architecture is the good way, but yeah, you need to start somewhere, I guess. Yep. So yes, thank you for watching. Uh, I guess good night for some of you. On my side, it's almost 7 p.m. Soon I need to eat. And yes, thank you for watching, and see you next week, same day, same time for the adventure. I'm losing my English. It's late for the next part. So yes, thank you, and see you around. And bye bye. Now it's awkward because I need to switch manually the camera. Okay, bye.